Hey everyone, let me show you how you can create and run your very first densely connected neural network. We're going to create a network with the Auto-Encoder architecture, and we're going to use TensorFlow to do so. Let's go ahead and take a look at the imports that we need for this program. We import NumPy as MP to emulate our training data. We then import TensorFlow itself, followed by importing the model class from TensorFlow, as well as the input and dense layers. Let's take a look at a function that uses these layers to create a model. We define a function called createModel that takes the input shape of the neural network we want as an argument. The function is going to create a neural network made out of dense layers in the shape of an Auto-Encoder architecture. We start by defining the input layer by calling the input class and giving it the input shape as well as a name. Now come the dense layers that make up the bulk of our architecture. In general, an Auto-Encoder starts with an encoder which takes the input and downsizes it to the size of the latent space, which is the layer in the middle of the network with the smallest amount of nodes. Then it uses a decoder, which is the encoder in reverse, upsizing back to the input shape. The idea for an architecture like this is that the latent space learns the most crucial information to represent the data, and it will either use that latent data to reconstruct the input, having learned how to compress it and what its most defining characteristics are, or it can be used to filter out some of the more characteristic information about some data we want to filter from the input. Now that we know the general shape of an Auto-Encoder and what its purpose is, let's build it. We start with an encoder block that takes in the input layer and has the same size as the input layer. The next encoder layer then downscales to 32 nodes, and then we downscale again, reaching the latent space. So in this case, we're looking for the 16 most defining characteristics of our input data, or the data that exists in the input data that we want to filter out. We then get to the decoder block, which only uses the latent space data to upscale and reconstruct something of the same shape as the input. Finally, we define the output layer and we build our final model class using the input and the output layer. And then our createModel function returns the model. Let's now create a model using our function, passing it the one-dimensional input shape of 64 nodes. We then have to compile the model in order to tell it what optimizer to use to get to the best solution, as well as the loss function, which is used to calculate the difference between the predicted and the expected output, and it tells us how wrong or right our model is in order for it to learn. We are now ready to define some fake inputs for our model in order to start the training. Let's call our input data xtrain, and let's call our expected output data ytrain. Before training, we can output the structure of our model in the terminal, showing how many layers it has, how many nodes each layer has, and what the amount of parameters are. And finally, you can train your model by calling model.fit, giving it the input data xtrain, the expected output data ytrain. We define the batch size as 8, which is the amount of inputs the model processes at once during training. We define the amount of epochs to be 100, which is the amount of times it will go over all the data in training. And finally, we set shuffle to true, as to not always train on the data in the same order. You can now run the program to train your own densely connected Auto-Encoder neural network. Hopefully you enjoyed this video and you learned something new. If you did, please leave a like. And if you want to see more content like this, consider subscribing. Peace.